Hello again. So we move on by describing the basic idea of cryptography and giving out some terminology that we will be using throughout the entire course. So the outline of this lecture, basically, we're going to talk about cryptography. So we are going to describe what is symmetric encryption. In the literature, you can also see it as private key encryption. To this end, we are going to describe the difference between stream ciphers and block ciphers and briefly describe how they work. Then we will move on to describe what is asymmetric encryption, which is also known as public key encryption, and also highlight the differences between symmetric and asymmetric encryption schemes. Then we will briefly explain what is a hash function, a cryptographic hash function, and how we can use it to protect the integrity of our messages. And then we have digital signatures and digital certificates, but these two will be explained in lecture number 3. Right, so what is the core idea of cryptography? So the core idea of crypto is basically secure communication, right? So to secure our communication, first of all, we need to make sure that Alice and Bob, they can securely establish a secret key, which means that we have Alice and Bob, the two ends, and they will start exchanging a bunch of messages with main aim to both of them come up with the same encryption key. Okay, a secret key that will be known only by Alice and Bob and will be used to secure their messages, right? Now, if they manage, these two guys, to establish securely a key, a secret key, then basically Alice can be sure that she's talking to Bob, and Bob can be sure that he's talking to Alice. So this is the first phase of the communication, let's say. Now the second phase is after they have established their encryption key securely and in a privacy preserving way, then basically Alice and Bob, they can start using the same key, okay, the key that they have established, in order to exchange messages in a secure and privacy preserving way, which means that all these messages M1, M2, M3 will be encrypted by using the key that has been established in the first phase. Now, by doing this, Alice and Bob will be able to protect the confidentiality of their messages as well as the integrity of the messages, right? Which means that if we have Eve, the malicious adversary, in the middle, who is overhearing the communication channel between Alice and Bob, she will not be able to say anything about the contents of the exchange messages, right? Now, availability is something that we don't really solve with cryptography. Okay, it's a different problem, and we don't really need cryptography to solve it. Good. So some basic terminology before we move on to describe the symmetric encryption. So first of all, we have the plain text, which is just the original message M that Alice is sending to Bob. Okay. Without any encryption. Ciphertext, on the other hand, is the encrypted version of M, right? So Alice wishes to send a message to Bob, but in a secure way, and to do so, she will have to encrypt the message M, and by encrypting M, this will result to an encrypted message, which we call the ciphertext. Now, in order to encrypt the message, Alice needs to use a key, some information that is used in a cipher, and is known only to Alice and Bob, to the sender and the receiver. Right, apart from that, we have the encryption and the decryption algorithm. So the encryption is a function that converts the plain text to ciphertext. Usually we can see it as E, which is the encryption function that takes as input K, the secret key that has been established between Alice and Bob, and the plain text message M, the original message that Alice wishes to send to Bob. Now, this function, the output of this function will be equal to C, which is how we denote the ciphertext. You might also see a different notation like ENC, enc of message M with the key K equals to the ciphertext. Now, the decryption algorithm is basically the function that converts the ciphertext to plaintext. We denote it by D, that takes again as input K, the secret key that was used for encryption, as well as the ciphertext that was generated by the encryption function earlier, right? Another notation is DEC, deck of ciphertext with the same key, and by applying this function with that key to the ciphertext, basically what you do is you are decrypting the message. In other words, you are recovering the plaintext from the ciphertext. Good. Now, what is a crypto system? So a crypto system is an encryption decryption algorithm plus the description of the format of messages and keys that can be used from Alice and Bob. Okay, so we have a plaintext message M. So usually, because this is a set, usually sets we denote them with calligraphic letters. So a plaintext message space M, which is basically all the possible messages that Alice can generate. Okay, all the plaintext message that Alice can generate. A ciphertext message space C, which is a mapping from, so an encryption is basically a mapping function that maps the message space M to the ciphertext message space C. Okay, so it's the ciphertext message space is basically all the possible ciphertext that Alice can generate. Apart from that, we have a set of possible encryption decryption keys, which is denoted by calligraphic K, and this is basically all the possible keys that Alice and Bob can generate and use in order to encrypt and decrypt messages. In addition to that, we have a crypto system has an efficient key generation algorithm as well as an efficient encryption decryption algorithm. This algorithm needs to be efficient in order basically to allow us to build applications that they will be using these functions without needing too many resources, right? In order to make basically our applications more efficient and the designs of our applications more realistic. So that was it, basically. Very brief video. Thanks, and then we will move on to the description of symmetric encryption algorithms. Thank you.